Hello everybody, and welcome to example 2 at the top of page 110 in the workbook. And this is another example to kind of illustrate the second fundamental theorem of calculus graphically. Alright, so let's read the question together here. Suppose that g of x is given by the graph below to the left, that's this one here, and we're defining a second function a of x to be the integral from -1 to x of g of t dt. And the first part of this question, part A, asks us to remind ourselves what the relationship between these two functions is. Okay, and kind of the key to seeing that relationship again is noticing that if you take the derivative of a of x, the function that's defined as an integral, the second fundamental theorem of calculus tells us that the derivative and the integral have to cancel and we just get back to g of x. Okay, so what that's really saying is that g of x is the derivative of a of x, or the other way around, we could say that a of x is an antiderivative of g of x. Okay, so we'll kind of keep that relationship in mind as we navigate our way through this problem. Okay, and next, we're going to gather some data about this function g of x. We're going to substitute in some numbers, figure out what the output values of a are, and then see if we can sketch a graph and see this relationship graphically. All right, so we're going to fill in this table, and these are calculations that we've done before, so if at any point you kind of get bored watching me do calculations, feel free to pause the video and maybe see if you can fill in the rest of your table on your own. Okay, and let's start with just the first number that we're substituting in here. Okay, so if we want to substitute -1 into a, then by definition, that's going to be, actually, let me scroll up here for a minute. Okay, we're going to always be referring back to this definition of a. So if we substitute -1 in for x, we are integrating from -1 to -1 g of t dt. Notice that if we start and stop at the same number of -1, there's going to be no area that we're talking about, so we should really get 0 for that first input. So we'll add that to our table. Okay, and every other calculation is going to be the same way. Then we'd move on to 0, substitute that in. Okay, so how much area is under the curve g of t between -1 and 0? Well, let's go up to our picture. So between -1 and 0, we're on this stretch of the graph that's constant. There's no area under there. So we get 0 again for that. Okay, and then moving on to a of 1, now we're integrating from -1 to 1 g of t dt. Okay, so let's see, from 0 to 1, now we're adding an actual triangle of area. I'm going to shade it here. And the question is, how much area is in that triangle? Okay, well, you can look at the picture and see what the base and the height is. We could go back to that area formula for a triangle. The base of it is 1 and the height is 2. So we'd be getting 1/2 1 times 2, that's one way of thinking of it. That triangle is going to have an area of 1 ultimately. Okay, so that's our output at 1. And we just keep going here. All right, so what about, I'm going to see if I can sneak in a of 2 before we scroll up here. Okay, so if we integrate from -1 to 2, we're going to get the 1 that we got above, plus however much area is involved between 1 and 2. That would be between here and here. Notice that we get kind of two really tall, skinny triangles involved, one up here and one up here. And those new triangles that I shaded have the same area. One gets added and one gets subtracted, so the net is to add 0, and we're going to repeat the number 1 when we substitute in 2. Okay, and we just keep going here. So we come to the number 3. What happens when we substitute that in? Well, we're going to take the area that we already had and subtract that square, which has area 1, and this triangle, which has area 1/2. So we're going to have to subtract 1/2. So 1 minus that 1/2, and that's going to give us -1/2, it looks like. Okay, and if you want to, feel free to pause the video here and see if you can fill in 4, 5, and 6 on your own. Okay, so were you able to fill in the last 4 entries in the table? Let's just run through those calculations together just to make sure that we got the same thing. Okay, so integrating from -1 to 4, we would be taking the -0.5 that we got above and then looking at our graph and figuring out what's going on between 3 and 4. Okay, that subtracts an additional 1/2, so we should be taking the -0.5 and subtracting another. That's going to get us a -1, it looks like. Okay, a of 5. We're integrating from -1 to 5, which means we're going to take the -1 that we had at the first, or at the step above, and go back to our graph and see what's going on between 4 and 5. Now we're back above. We're going to add a triangle that has area 1/2. So -1 plus 0.5 is -0.5. Okay, almost there. Okay, so if we integrate from -1 to 6, we're going to start with the -0.5 that we already had. Okay, and what's going on between 5 and 6? Let's see. Between 5 and 6, we're going to add a square that has area 1 and another triangle that has area 1/2, so we're adding 1/2. Okay, so it looks like we're going to get 1, and sorry for all the scrolling up and down. This screen is kind of small. Okay, and then finally, a of 7, let's see. So we'll take the one that we got at the step above, sneak a peek at our graph, and between 6 and 7, it looks like we're adding another 2 squares of area. So we'll add 2 and get 3, and that appears to be our final value. Okay, so we have completed the table for a of x, and now they're asking us to sketch a rough graph of this new function that we created. All right, so I'm going to scroll up yet again so that we can see the graphs, and we'll see if we can plot the points on this new function a of x that we've created. Okay, well, let's see. So maybe starting here, we've got the point -1, 0. Then 0, 0. Okay, we just keep going. 1, 1, 2, 1. 3, -0.5. That's going to put us down here. 4, -1. 5, -0.5. 6, 1. And 7, 3. Okay, now what we're going to do is in the second half of this example in the next video, we're going to try and kind of connect the dots and see what the rest of the graph of A looks like. Before you watch that video though, I'd like you to try that experiment. Okay, take the dots that we just plotted for A of x and come up with what you think is a reasonable graph for A of x, and then on the next page we'll check it out and see how it went.